Hi, I'm here one-on-one with Malai Sankarasubbu from Saama Technologies. Malai, nice to see you.
Yeah, hi, hey, Taren. Thanks for having me here. Pleasure to talk to you.
It's our pleasure. Um, Malai, tell me, what are some of the problems being solved by AI-enabled analytics, and what benefits can be expected?
So, way I look at these problems are like, typically from a pharma clinical trials perspective, that's the space we play in, right? Like I live and I like to start with probably an example on that. I live in South Bay in San Francisco, right? And the office is in Campbell. So that's about 30 miles, right? So if I have to walk from, let's say, my home to office, right, it's going to probably take me 4 or 5 hours for me to reach there. If I run, I'll probably reach in a couple of hours, right? If I have a bike, I'll maybe a little faster, right? If I have a car, I'll be going a little faster. I can say, you know what, I can walk fast, but that's the optimization part of it, which we do, right? But the same problem could be solved more effectively by just having a different kind of tool altogether, right? That's what AI does to this one, right? To clinical trials or pharma in general, right? It enables problems that were never been able to solve before by traditional rules-driven programming technique to be solved more effectively by using AI. So the application for AI in pharma is like very generic, right? But in clinical trial space, the maximum value that we are seeing right now is actually ability to collate the data, right? And since it's all study driven, every study is a different experiment altogether. Ability for you to actually standardize it and raise queries, do data management and other activities on top of it. That is where we are seeing high value right now.
So to continue on that theme, how can AI automate clinical trials and what results can be delivered then?
Okay, so I think it's I answered some part of the questions, some part of that question in the previous one. But
Yep.
what it really means is, so every clinical trial is an experiment by itself, right? So for example, if I'm running a diabetic trial, I'm going to capture a different set of data points. But when I have to submit it to FDA, I need to bring it into a standardized format, right? That process is very, very time consuming. Okay. What if there's a process or a learned machine learning approach, like learned algorithm or learned system approach, which can learn based on the past historical trials and try to standardize the data a lot faster with human in the loop in between. Since we are dealing with human lives, you need to be extra sure that it's not doing a mistake, right? The data standardization part, ability for you to clean and get the data into a standard format for like biostats and others to actually come and analyze it. I think that is where the value is very, very high, right? Apart from that, even like the data standardization, like data cleanup is another one. For example, right, you enter as, for example, at a site, like a doctor or a nurse, right, registered nurse enters data for a patient, right? From the point that is entered in the site to getting the data cleaned up, it's actually happening under 24 hours, right? How does it happen under 24 hours? It's actually driven by machine learning for actually identifying the discrepancies in the data or the data point that we are talking about. So what that really means is, like, for example, age is misentered, right? Someone is 40 years, right? And they have entered it as 140. I mean, yeah, I mean, there's a possibility someone lived to 140, but not always, right? So that has to be marked as a discrepancy, right? You can't write rules for everything. So these have to be understood by the system, learned, and the query has to be raised at a data point level. So that's what I'm talking about, data cleanup. Data standardization, data cleanup, ability to get access to data a lot faster are the areas where we are seeing high value right now.
Very good. And what advice do you have for anyone who's exploring AI for clinical research, and what are some of those first steps they should take?
I would say the first step is actually ability to have, there are multiple things in this, right? It all has to come together for you to solve this problem. Okay. The first step is actually identify the right kind of use case for you to go after. So what I mean by that is the one that you could actually define as the right ROI, right? Return on investment. So don't take something that it's gonna boil the ocean, right? Pick a small use case that actually has high value and that could deliver the business value that is needed, not the technical value, the business value that is really needed. Talk from outcomes perspective to your executive leadership rather than saying, this technology is cool. We have to go through that. I lead a research group, but still I have to talk outcomes to my executive leadership to convince them to invest in this particular thing. So if I do this, internal onboarding process, which used to take a long time before, has been like, we have cut it down to like, under 2 weeks now for a study, right? So that is quite a powerful thing to make. That's optimization or savings or gains inside Saama for any study onboarding that we do, right? So the other thing is like, ability for you to have historical data or ground truth data. Okay, so you need to put some time and effort to actually collect it for the use case that you're going after, right? That's a not so sexy part of doing AI, but that's the most critical part of doing AI. Okay, have that, right? And then like, assemble the right kind of team. Either it can be internal or external, whatever that may be, right? Like, set the right kind of expectations to them, saying that what is considered as a success, what is considered as a failure, right? Define your metrics properly. That is really key, right? It's not a fair, I mean, it's not a gold dust, right? Say that like, go beat your wand, like, magic wand, like Harry Potter, like, it solves everything. No, it doesn't work that way, right? You need to define your problem. You need to know what questions to ask, right, to a model for it to learn. Okay, so that is another major aspect, right? And I would say the fourth most least talked about thing is expectation management, right? The term AI sometimes, like, creates like so much expectations, right? Even if the outcome is successful, it still fails to deliver the value that it's supposed to, since people were expecting a lot more, right? So take a small use case, set the right kind of expectation, talk outcomes, collect the ground truth data, set the right kind of team, and invest in compute too. I mean, like, you need GPUs for doing some of this, right? That's the way I would put it for someone starting in this space.
Well, I thank you. Those are excellent tips. And thank you so much for sharing how to best optimize AI in clinical trials. Thank you for joining us.
Thank you. A pleasure talking to you, Taren.